I was told you guys have access to it beforehand, so how many of you actually read it?
I've read it in all details.
Okay, I assume some of you didn't read it, so there is still a reason for me to present about it. Okay. I know my students never read anything, they don't even buy textbooks. So I assume if it's not in a presentation, you don't know about it. If you want to know more, if you have questions, I'm happy if you follow me, email me, collaborate, but I'll try to kind of do a self-contained presentation of the topic. Let's see if I can figure out how to work this magic. Okay, so if you know history of artificial intelligence, you can trace a lot of it to work of Alan Turing. He definitely had amazing contributions to computer science, but specifically in AI, he's known for probably the most his Turing test, the so-called imitation game, and it is probably the most popular way of determining if a machine is intelligent. However, what it really measures is how human intelligent the machine is, right? It's not helpful to be super intelligent and make very intelligent answers, which quickly will be discovered to be artificial. So you have to make mistakes in typing, you have to be kind of slow in typing, you have to not be brilliant mathematically. And Turing himself talks about that in a paper about the need for a machine to recognize those limitations and to integrate them into the answers. But surprisingly, there's been very little attention paid to this aspect. So everyone's trying to develop more capable devices, never looking at this limit of human capability in any formal way. So what the paper does is kind of formalize this notion and suggest that it may be very useful to look at it some more. So what is it like to be human level intelligence but not greater than that? And how does that apply to all sorts of different subdomains, mathematics, psychology, and so on? Not surprisingly, there are fundamental differences between capabilities of people and machines. We can concentrate on few obvious ones, but there are many, many others. So for one, computers are great at computing. Not surprising, they can follow long chains of algorithms, perform very significant computations, data mine. People are not as great at that. Likewise, people have very limited memory. Computers have almost perfect memory, whether it's long-term or short-term, they're much superior to us. On the other hand, people have amazing common sense. They can quickly figure out ambiguous sentences and fuzzy visuals, whereas computers are not that great at that. With respect to rationality, we are capable of creating very rational devices, strictly statistical analyzers, whereas people are usually not so rational and have a number of well-known biases. So what is specifically this concept of artificial stupidity? We want to study human limitations and to formalize them in different domains and to be able to encode similar flaws, similar properties into a machine on purpose. And I'll, of course, explain why it's useful. But this is the general idea. So if you understand this much, unfortunately, there is alternative use of this term, artificial stupidity, as kind of related to natural stupidity, and lots of funny jokes about that. But we explicitly mean this codification of natural stupidity, natural human limits. So why would you want to make your computers dumber? It seems like we started at that point already. Well, there is quite a few useful applications. So obviously you needed to pass the Turing test itself. So if your initial goal was what Turing hoped for, you need to understand what the limits are in order to succeed. There are also quite a few applications in terms of developing products. So whatever you're talking about, domestic robots, sex robots, whatever you're flavor is it's wonderful if they have good understanding of human capabilities and can relate and can interact in a kind of equal kind of way. If you're designing games, it's nice if you actually have a reasonable chance of competing in a game. It makes it more fun, more interesting. In general, this limiting of power differential between people and machines could be quite useful for safety reasons. And if you scale your systems beyond what we have today, you're trying to achieve superintelligence at some point, I think it would be necessary for successful value alignment to understand completely what it is you're aligning to the model for human intelligence, human sensory system, and so on. So what we need to do is not so much a lot of original work, but maybe collect relevant information from a number of other fields. We are interested in research from psychology, sociology, economics, mathematics, anything to do with what are those limits in humans. So we know there is kind of limited attention capacity, limited recall, different interpretations of statistics, but there are also kind of interesting observations we can make about human visual system, for example. How many of you can actually perceive this illusion?
I definitely see it moving.
Okay, so I shared this on Twitter and I got something like 250,000, I wouldn't call them likes, but interactions of some kind, which gave me a grand total of 1 new follower. But people seem to definitely understand this and react in some interesting ways, whereas a machine which would not have this bug in their visual system would not be able to relate and connect. So that's pretty much the example of what we want. We want full understanding of what it's like to be a biological human. There are some trivial examples I can give you from different domains. So the famous one, probably everyone heard who took some psychology courses, is this magical number 7. Speaking of short-term memory, we usually can remember plus or minus 7 chunks of information. So depending on how you chunk it up, it could be characters, symbols, words, sentences, but usually that's the number, and we see it show up in many areas of life. So for example, phone numbers typically have 7 digits because that's the best we can do on average in terms of memorizing them. But such constants are not readily available. If you're programming an AI and you would like to have access to, well, what are the limits for different human properties, it's not something you can quickly look up. There is not an API for it. So that seems to be the limitation we want to address. Another example which has been studied extensively, but again is not directly available, is a set of so-called cognitive biases. There is quite a few of them. We try to not just list them, but explain how they may be useful in specifically creating safer intelligent systems, what those limitations may imply. If you think about it, AI started with a lot of work on heuristics, which were exactly that, shorthand limitations in computation to improve efficiency, improve performance. But then AI does it, we say, okay, it's a great heuristic, very efficient, but then people do it, it's a horrible bias, we need to fix it. But that's essentially, we're talking about the same mathematical approach to solving problems. So what the paper does, it's not an experimental paper. We didn't code anything, we didn't run any experiments, but we proposed this essentially direction for doing additional work where from multiple fields, it's highly interdisciplinary, we want to understand physical, cognitive, and cultural properties of people and formalize them to make them easily accessible to anyone programming AI. So here, for example, you have some extreme properties of humans as physical systems. In the left bottom corner, you can see an example from recent experiments on moral judgment about self-driving cars from different people around the world. And there are some very difficult to predict differences, cultural differences, who the self-driving car should sacrifice. Is it young people, old people, men or women, poor or rich? And things like that need to be encoded for a system to understand what's going on. And again, I don't think it's quite readily available at this point. So some examples of where this has already been applied or where we will see it applied in the future. Games is one example, and pretty much all the existing papers on this subject, which is like one or two, are in a domain of games, where people quickly realize nobody wants to play against God-level AI. It's just not fun. If you're playing chess and it destroys you every time, it's boring. So you should be able to adjust the level of your non-playing characters, your opponents, and whatever, it's from easy to impossible, or just sometimes make mistakes. It's definitely part of modern game design, where you have to integrate such human limitations. If it's a shooter game, you want the opponents to miss you sometimes, and so on. Another example is specifically with chatbots, and we see it a lot for chatbot competitions such as Loebner Prize. Winning bots make a lot of mistakes. They pause, they type with mistakes, and I think one of the best winning strategies is just to kind of remain silent for a while and seem very deep and interactive, interesting, but it could be a bug in code and people perceive it as quite high-level performance. So we saw this exemplified with chatbots, and more recently we saw demonstrations of Google Duplex system, and that's quite impressive system. Very natural voice, allows you to make phone calls to different businesses, make appointments. But what made it sound very human is all the kind of human like let me think, wait, sounds, which it made for no reason other than to sound dumber than it was, so more human by extension. So that's, I think, something again we see show up even in existing systems, but again without any formalization of what are the optimal delays, what we need to say to sound even more human, and so on. So that's some examples of application. The paper came out very recently, already started to gain some citations, which is nice to see. It's not formally published, it's just a preprint and archive, but it quickly went viral. I don't know if it's the catchy title of Artificial Stupidity or people actually think it's a brilliant idea, but quite a few media outlets and a lot of international coverage was given on that, and the comments for those publications are gold mine of artificial and natural stupidity for sure. We quickly assembled a data set from that. So to kind of conclude, what we're trying to do is start this direction of research where we're collecting necessary data from different domains on human, cognitive, and physical limitations, different properties and factors. And the goal is to formalize it, make it available to AI researchers in order to make more customized, safe, and secure systems, and with a long-term plan of assisting with value alignment of AGIs, superintelligent systems, and better understanding humans in the process. So with that, I'm happy to switch to a discussion mode and answer any questions, or recruit you guys to work on this project as it works. Let's see if I can stop sharing. Okay.
Okay. So I'd like to say thank you to Roman Yampolsky for this presentation, and then I'd like to hear if there are any questions.
I would like to ask, have you also considered artificial wisdom, which would also kind of different from artificial cleverness? Because right now, what people are mostly working on is how to make the AI clever and find any very difficult, maybe complex algorithms that solve some problems, but maybe the problems we have are actually stupid problems and we should not solve them at all. So what about wisdom, which is more not about having some convoluted solutions, but instead changing our viewpoint or goals?
I think I missed the beginning of your question. I got the end of it, but beginning was kind of cut off. Can you repeat that part?
So I was asking have you thought about artificial wisdom? So right now we were opposing artificial cleverness with artificial stupidity, but I think there is third component third dimension, which is artificial wisdom. So we don't have any convoluted algorithms. Instead, we have different viewpoints. So we might simply have very simple solutions for very complex problems if we simply change our viewpoint.
Not sure I have a brilliant idea here. Changing your viewpoint as in changing our values to make them easier to fulfill? Is that what you have in mind, or?
Yeah, somewhat. So what if we have some artificial intelligence system that helps us to change our viewpoint and therefore get our problems solved without huge side effects?
So that is something to consider, but it's also considered a safety issue, right? If a system tries to modify you in order to make its processing more efficient, there is a danger of losing your utility function. You stop being yourself, right? If you are modified into someone who enjoys paper clips and that's it, you kind of fail to preserve your identity, at least in the short term, for sure.
Yeah, I think there is some danger. Why I thought that it would be useful is that usually when people invent some new technology, they very soon utilize it to maximum extent over the world. And that's certainly a dangerous approach. And when you have you are instead changing your viewpoint, you don't have to utilize new technology to the maximum extent. And I think, for example, paper clipping would be still utilizing the technology. And what about the cases where you only change the viewpoint, but do not utilize too much technology in order to fulfill this new viewpoint?
So in general, I have started thinking about values and in the context of value alignment. And just because we call them values, it doesn't mean they're actually valuable, right? They're pretty randomly assigned at birth based on your culture. So there is something to be investigated in terms of can we be happier? So as a foreigner in the United States, I'm quite happy to enjoy unpopular sports and not care about popular ones. So I save on tickets. I don't have to go to Super Bowl. It's very good. I wonder if this can be streamlined somehow, but I haven't done any published work on it.
I have a question. When I looked at the list of biases, I thought of another candidate, which is that humans in general prefer to have stories about what they do. They don't, of course, sometimes we act based on pure intuition, but we prefer to be able to explain our actions to ourselves and to others. And this seems to be an important issue in particular with the kind of AIs we see, neural networks that give suggestions that are unexplainable, basically. And we would prefer a safe AGI to take actions, to be biased towards actions that it can explain, just like humans.
Right, and that's another subject I'm very interested in and slowly collecting literature and planning and doing things. One thing to observe, so we have this expectation that neural networks, artificial deep neural networks, will be able to explain themselves. But that's not true of people. Then we do experiments on split brain patients, for example, we quickly discover we mostly make up bullshit excuses for why we do things after the fact. So it seems like we have a much stronger requirement for AIs to be able to explain things. If they are truly super intelligent and make decisions based on, let's say, million factors with unique weights, any explanation they can give us would have to be dumbed down, bullshit story, or worse, some sort of mind hacking where they just make you happy with the explanation. So even that part could be quite unsafe, and I don't think you can understand the full reason for something.
So something I really liked about your paper is I think I've spent a lot of my time in AI thinking about super intelligent or more superior than human intelligence. But I still think I am actually really curious what your thoughts are in the space around safety, around even human level intelligent AI. Humans in general can be dangerous to me. They're not safe. I wouldn't call them a safe intelligence. And even going one step down further than that, like what level of stupid AI is like still safe? I can imagine a lot of different scenarios where the AI is sufficiently stupid but still dangerous to us. So it doesn't seem like those two vectors are necessarily combined together. What are your thoughts on that space?
So I agree in general. Stupid people are quite dangerous. I deal with them a lot, and they cause most of nonsense in my life. I guess the difference is between catastrophic damage because they can outsmart everyone versus just kind of screwing up locally and whatever. You had a car accident, somebody died. I think there is a direct proportion between intelligence and level of damage you can cause, as well as controllability and level of intelligence. So the more intelligent system is, the more it is independent and uncontrollable. I don't know if you had a chance to read my paper on differences between AI safety and cybersecurity, but this safe human problem is something I talk about explicitly, and I'm trying to reduce problem of making safe AI to the problem of making a safe human, which we, of course, failed to do for millennia with culture, laws, prisons, bribes, you name it. Nothing worked so far.
So that's really interesting. I haven't looked into this space, and I would definitely be open to recommendations if anyone has it. Just looking at definitions around safety. I think your point about humans not being safe is kind of interesting. I'm not sure you're pointing out I don't have a good definition of what that means, like a very rigorous idea of what it means to be safe. So I would assume this is the audience to give good recommendations in that space.
I don't think there is a very formal definition, but just the idea of trust. Let's say we want a very safe human to work with very sensitive information. So something like NSA and Snowden, right? We have polygraphs, we had background checks. None of it worked whatsoever.
So I have a couple of related questions. So the first one would be, if you were able to implement artificial stupidity into an AGI, how would you keep it stupid enough that it can't self-modify so that it's no longer artificially stupid, and yet intelligent enough that it's still capable of doing real-world work? And the related question is, if we were able to successfully implement artificially stupid AGI, and yet we still had a geopolitical system somewhat like our current one, what's to keep America from making an AI with IQ 100, and then Russia says, oh, we can outcompete America and still be safe by making an AI with IQ 115, and then China says, oh, well, we can go up to 130 and still be fairly safe, and so on until we're just back to the paperclip maximizers.
Right. So with self-improvement, when we talk about artificial stupidity, we are kind of anchoring an average person. So IQ of 100, that's actually quite low. If you think about top machine learning researchers, people capable of modifying code and improving it, we're probably looking at much higher levels, 130, 150, and so on. So hopefully it simply would not be smart with those restrictions to make those improvements. But we haven't gotten that far. I mean, at this point, I'm just happy if I find some numbers to put in a data set. As far as arms races between different governments and governance of AI, that's a huge problem and unsolved one. As far as I can tell, if problem of creating AI is huge, like Manhattan Project, you need a government, you need Google-sized corporation, maybe governments can agree or sign something. If a person can do it in a garage on a laptop, then it doesn't really matter what we agree on, whatever standards we propose. It's just going to be done immediately by someone just to, get famous or collect financially. So very, very difficult to say anything about control from the governance point of view.
I have a question. It seems like many of the actors that are currently or plausibly in the future pursuing AGI are things like military intelligence, advertising giants like Google and Facebook, or researchers trying to do the Turing test. And it seems like all these three kinds of projects have deception of humans as a rather key component. You can't. If you want to do a military intelligence project, you need to be able to explicitly model. The AGI needs to be able to model how to cheat other people, and advertising probably the same, I guess. That seems very problematic, right?
Huge. So there is a few directions I'm looking at with this, and one is artificial propaganda, just kind of optimizing effect on human psychology from running lots of experiments and seeing what works. We kind of saw it with influence on U.S. election, right? You can optimize ads to trigger just a certain set of responses and people from unrelated data. Okay, I like spicy food, so that means I'll respond well to this message. Another one, I showed you this visual illusion, right? So those are right now designed by people for people. But what happens then? Machines are capable of coming up with same type of illusions, but not just visual, but in other domains, textual illusions. We had a paper actually from the same group who's working on adversarial inputs for artificial neural networks, come up with some images for people. So they took a picture of a cat, flipped a few pixels, now it looks like a dog to most people. So that's a proof of concept, but I think it's going to get to the point where I show you a water bottle and you vote for me.
Scott Alexander wrote a post for Halloween about a fictional story about some researchers finding a way to do this, a scissor statement, I think they called it, which was exceptional, a short statement that was exceptionally capable of influencing humans. It's a funny story. Scott Alexander at
I'd love to look it up. If you can post a link to that, I would definitely take a look. I'm so behind on my reading, I need some super intelligent help here to just keep up.
Some of those examples of artificial stupidity that you mentioned at the beginning, there were limitations built in to the performance of the machine. And they were essentially deceptive in nature, weren't they? Things like, you gave the example of the duplex demonstration, the hesitations, and the ums and ahs and so on, which are designed to fool the other person into thinking it's a human they're dealing with, which you can justify as saying it feels more natural. But I hope that in that one area, that one limited area, I hope that we'll accept that a digital assistant like that, phoning up to make an appointment, would announce that it was digital and not human. And in that case, I mean, I don't really need it to say and ah. Obviously, it's no good if it talks at 100 times human rate. It's got to talk at a rate that I can understand, and it's got to, if it presents some sort of logical argument, it's got to do it in steps that I can understand. But apart from that, I don't mind these artificial failings are rather deceptive, I think. And, I hope that we don't have too many of them.
Well, they are by design kind of artificial. They don't have to be there. California just passed a law saying that chatbots would have to self-identify as bots. So in a way, there is some effort, but I think we need to do some studies on psychology of human enjoyment of those interactions. It's quite possible that we just relate better and enjoy better conversing with other what we think are humans. And as those systems become more 3D, more interactive, more humanoid bodies, it will become probably more so. So right now we're talking about just voice on a phone. What if it's a sex robot, for example, right? You probably want it to be pretty good imitation of a biological body to some degree. even if it didn't have to.
Yes, I might prefer for it to have a few.
Again, whatever, could be just Energizer Bunny.
Yeah.
I have a quick question. In many of your proposals for the artificial stupid AGI, it's not completely clear to me whether you expect it to have internet access.
Specifically in this paper or in general?
In this paper, do you expect that? In thinking mostly about.
I don't think we explicitly addressed it. In my papers on AI boxing, I strongly encourage no one to connect their AGI projects to internet, probably ever, but this can be decided, maybe some sort of limited North Korean internet access.
So, how promising do you think this is for superintelligence? Because your paper doesn't, at the end you seem to suggest that there's not really much of a way to extend this. But do you have any sort of inkling for what you might do? And by the way, I enjoyed the paper. There was quite a lot I hadn't heard of.
Thank you. So it's a contradiction in terms, right? You can't be human level stupid and then artificially super intelligent. So one or the other. But this is useful for when you modeling people and you're trying to create some sort of value alignment to at least understand what are the values, why are values in that level, can people appreciate something in this range or not. So I think just having this information would be a useful tool, even if it doesn't end up being some magical bullet.
So it seems to me that you're really talking about two distinct concepts here. One is having computers be able to model human flaws for the purposes of understanding humans or pretending to be humans or what have you. And then on the other hand, you have trying to actually limit the capability of an AGI to human levels. Is there some connection between those that I'm not seeing, or like?
Well, it's the same data set you would need, same information.
Okay.
You can have multiple applications for this data, but you need to collect same information on same entities.
Could it be that common sense is the intersection between artificial stupidity and kind of wisdom, in the sense that the agents, let's say humans or robots, don't do too much of their own thinking from the one hand, so they are stupid in some sense. But on the other hand, common sense, even if it's irrational and so on, so it's stupid, it somehow works. So it has passed the test of time. So it is some kind of wisdom. It's practical.
All right, all these biases evolved exactly because they work. I mean, we try not to judge individuals based on statistics for groups, but it works if you have no priors, right? That's why those things exist.
Mm-hmm. So I think being artificially stupid and artificially wise is not opposite things. It's the same in some sense.
Well, if you look at human genius, usually they brilliant in one narrow area and really not that capable in many others. So it's possible there is some buffer overflow from genius to stupidity at some point, but I haven't looked into that.
I was more like having in mind that every person who is having a common sense average person who is not too bright has this conjunction of both stupidity and wisdom. They don't think too much, but they do things that work.
So we are very resilient. I'm actually quite impressed how terrible you can be at making decisions and still kind of be okay as a human, right? You still have a job, you're still probably not dead in most cases. I see people make mistake after mistake and yeah, okay, we still got a job. So there is a lot of tolerance built in for this, I think, through society, through our legal system, which assumes that we're going to screw up like that.
I have a question. Do you feel that a lot of the economic potential from AGI comes from the fact that they are indeed different from humans in that they are perfectly rational and unbiased? That might be why we want to build them. And in this case, we want the opposite of artificial stupidity in practice. I have lost connection.